welcome amongst us Mr. Rajat Prusty. But before that, may I request Mr. G.M. Kapoor, the President of Calcutta Management Institution, just to formally inaugurate the session.
I think we have already inaugurated the session overall formally. This is the keynote address of the session. So anyway, once again, I take great pleasure in inviting Mr. Prusty to deliver his monthly talk shop program. And I think this again a very topical subject on which he is going to speak. So I'm sure it would be interest to everybody, not only in industry but even in the environment. So over to you, Mr. Prusty.
Good evening. Thank you, Kapoor sir. It's a great opportunity for me to have a lot of interaction with all of you. In fact, in the first session, I could hear many suggestions, and those are really good suggestions. Definitely, as an executive team, we will work on those suggestions and see that what real change we can bring for the CMA. Being the member, first time I am presenting you a topic which is a buzzword of CO2, you all know. And this is a difficult topic, but I know that we, each and everyone, contribute for that, both in positive way or a negative way also. So, the topic of today, what I want to brief is, what is the global prospects, what India wants to do, what industry want to do, and what as an individual can contribute for that. So with that objective, I am starting this presentation or discussions. It's more discussions. It will be good that if there is any question or other thing, we can also discuss during the presentation or after the presentation also. So what I discuss is, these are the topics I will be covering: the net zero goals and CO2 emissions, then the pathways, cement manufacturing and CO2 emission, because this is why I say that I am from a cement background, so I can highlight more on that, because CO2 emission of cement is also high apart from the aluminum and steel. CO2 reduction measures, what are the measures which are available today and what companies are doing or industries are doing. CCU, CCUS, carbon capture and carbon capture utilization, storage, what are the long-term measures, how it will be done. Digital transformation, how it can help to CO2 reductions. And our road ahead, what do we want to do as an individual, as a company, and as a technology point of view, and the policy point of view. So I'll brief this presentation with this 6-7 areas. We'll start with net zero goals. As you know, UNFCCC, it's a race to net zero. It is to achieve 1.5 degree ambition. That is the peak by 2020, and that should be half by 2030, and net zero by 2050. That means we do not, and as per the global requirements, the temperature of the earth should not go beyond 1.5 degrees centigrade. Based on that, what India has developed in the NDC, if you see, these are the 4 baskets. One is the lifestyle for environment. That means 1 billion people will change their lifestyle. Pro-planet people will be there by 2028. From 2022 to 2028, that means 100 crores of the people will be the pro-planet. That is the thought of India. Second is reduce emission intensity by 45% by 2030 from 2005 level. Third one is 50% of our electricity what we use by 2030 it will be only from renewable, avoiding the fossil fuels. Fourth is the net zero by 2070. So these are the broader 4 areas where NDC has determined for India, and based on that there is a progress also. If you go to the website of NDC, then you will find that there is a lot of progress on this. I just want to say that for 2030, what we have discussed as the country point of view of 50% renewable. Here already it has been reached to around say 40 to 43%. That means we will be there before time. Today's power requirement will be roughly around say 400 gigawatt, out of which 200 gigawatt is renewable energy. So by 2030, when the requirement will go to 500 plus gigawatt, then we will be much ahead of 50%.
This data you are talking about global data or India specific?
This one is the India. That one is the
45% reduction.
This is India.
India data.
This is India.
And 45%.
Everything is India. This all are for India only.
Okay.
Next. And if I see of course this data is 2021 because that is the last published data. If I see what are the global greenhouse gas emissions, here you find that 55,760 million tons of CO2 equivalent that is being generated globally.
Sorry.
Out of which you see that the 5 countries who are contributing around 50% of the global emissions. That means China is contributing 26%, USA 10%, India 7%, then Russia 4% and 3% is the Brazil. So our contribution to the CNG gas emissions is around 7%. Now I'll come to India. Like what are the sectors who are contributing these 7%? And the quantum also. Here if you see the total India generation is 3800 or 3823 million tons of CO2 per annum. If you categorize it in different baskets, electricity, the power generation contributes very high, 31%.
All right. Stop.
Then comes the agriculture with all activities. With segmented, you can say these are the contribution of each and every activities that is contributing around 25%. And the industry, normally we always say that the industry is contributing maximum CO2, whereas you can see only 25% is the industry is contributing. Of course, partly power is also comes to industry. It's not that the power is not used for industry, but if you see overall 24% is used, out of which the top one you can say iron and steel, then cement and others, then other industries. Then here you can see the transportation is 8%, waste is 6%, and the building is another 4-5%. So overallity point of view, if you see 3 areas which are consuming more, one is the electricity, power generation, agriculture, and the industry. Now again, if we go, I just try to say that to make a thumb rule or a number point of view, if you want to produce 1 ton of crude steel, how much CO2 emission typically it is there? Of course, it will be very 0.1 or 0.2 this side, the other side, but roughly it is 2.5 ton. And for 1 ton of cement, it is 0.6 ton of CO2. Coal-fired power plant for tons per million megawatt or megawatt hour, then it comes 0.9. That means each unit what we are saving or will be saving will be around 0.9 kg of CO2 I can reduce. Alumina, then it comes around 20.8 per ton. So what are the pathways for the net zero? If you see, this is the global net zero pathway. These are the direct emissions, and these are the other means where we are reducing. As in 2020, our direct emissions are very, very high. That means direct CO2 emission for carbonations. Gradually by 2050, you can see the all other activities we are improving as per the global framework. As a result, here when you come here, then all these activities, I think it is visible to them. Is it visible?
Yeah.
Yeah, visible. So all these activities the savings, the other things, the timelines point of view has been done. As a result, by 2050, because for global, they have taken a target of a net zero by 2050, but for India, we have taken a target of 2070. So this global framework has been prepared activity-wise to ensure to reach to the level of net zero. Now, India, now I'll come to a little bit of one particular sector, that is cement. Cement, we consume around say 2020 data, it is 252 million tons. Because if you say our actual cement requirement was around 200 million tons and 0.6 multiplied, it will come like that only. And of course, steel is also of similar nature, only 250 million tons. And by 2070, the demand of cement will go to 2000 million tons. Based on that data, this CO2 generation today of 250 will go to 1316. That is the assumption without doing anything today. If I project it for 2070, what is my production requirement, what is my carbon emissions, then it will be 1316 is the requirement. But what is the plan in India for decarbonization? One, cement use efficiently. How do I use efficiency of the cement? That means I need to improve the strength of the cement. I need to use the workability of the cement. I need to use the additives which will improve my strength. So that will help India to reduce by 20%. SCM, substitute of cement materials, that will come around 16%. And there are new binders also, it has started coming, but the contribution as of now is very less. Decarbonization of electricity, already all cement industries are doing, that will have a reduction of 6.2. And clinker efficiency, the way we are now improving our clinker, because clinker I'll come to the next part, that how cement is being manufacturing for a next slide. But clinker is a base product, base requirement for manufacturing any cement. And when the productivity of the quality or the reactivity of the clinker improves, then automatically the requirement percentage in the cement manufacturing can reduce. As a result, that will also help. Of course, there are some policy guidelines is also required to reduce it. BIS. Then comes the alternative fuels. Because nowadays all the industries are using alternative fuels to replace the fossil fuels, municipal waste, RDF. There are many hazardous wastes which are available in India, which are being used with a proper system and a proper processes of like AFR, pre-processing, co-processing. Platforms are being created with huge investment. That is really helping to the nation. And parallelly, this is also helping for the industry to reduce the cost. Then last, the CCUS, that means whatever, if you do all these activities, then also in cement industry, we are not going to get net zero unless until we do some mechanism to capture the emissions from the preheater tower, the carbon CCUS, carbon capture, utilize and store it. Unless until we do that, we cannot reach to the level of net zero. So this roadmap has been prepared for India, and continuously ministry is also working on this and discussing with all the industries like cement industry, since I specified, and the cement industry. Similar way they have done it for the steel, similar way they have done it for fertilizer, similar way they have done it for aluminum industries. So here just I try to put a capture on the CO2. This is for iron, the steel manufacturing. Here also you can see the base is 240 million tons, and there also if you see what are the activities they will do to reduce to the level which I discussed for the cement. On a similar lines, the natural gas will be replaced with the hydrogen gas, and obviously there also a lot of activities will be taken in the processes of manufacturing of the steel, like the power use, then other elements which will help to reduce the CO2 generation. So these are the roadmap has been prepared to reach net zero by 2017 for the steel manufacturing also.
Sir, in the earlier slide there was something called decarbonization.
Yeah, I'll tell you that decarbonization. So here just brief you for the benefit of the audience. Like what are the process of cement, broader perspective of the cement industry. One, yes, the mining part and the crushing part. With the cement, we need limestone. Then only we can manufacture the clinker. And for that, we do the mining. Then do the processing of the ore. Then do the crushing of the ore and prepare a raw material for manufacturing of the clinker. So there, the electricity consumed due to the preparation of raw material, given a equals potential also, that we generate the carbon emission. Then the main art of the cement industry is part, clinker manufacturing, where we consume all type of energy, especially the fuel energy. Fuel means coal, petcoke, everything, and that quantity is very high, and the power energy. So consideration of carbonates, then combustion of organic fuel combustion in the kiln, and the electricity. These are the four things where we really do the emission. Based on that, you can say that 20 to 25% of the CO gas released to the atmosphere. Then the finally comes to the grinding part. But just for brief, I'll just tell you that there are one are the clinkering unit parts, and there are multiple grinding stations also there for any cement industry. With fact that the mother unit is the clinkering unit, and in the clinkering unit, the combined with the grinding is there, where to manufacture the total process end to end, and finally transport this clinker to the grinding station to nearer to the market to reduce the logistic cost and reduce the carbon footprint also. And there they grind the clinker with slag and fly ash, so that the manufacturing part is like that is 60% or 50% depending on the type of product of the cement. The transportation cost can be reduced, and the nearby sources, especially the power plant, the steel plant, where it can put a grinding unit, then the carbon footprint can be reduced. So now, both in the business point of view, it also it makes sense, and from the point of the reduction of the carbon emission. So, what are the types of cement? So there are four types of cement. Normally for the BIS, there are another 4-5 type cements are there in other countries, but mostly these are the four type of cements we use in India. One is the ABC. This is not an environment friendly cement. Though we manufacture it as per the requirement or the specific jobs, but this consumes very high CO. Say, as I told you, our average is 617, whereas UPC consumes 842 kg of CO2. That means here you can say that the percentage for the clinker we use is 95%. Only 5% of gypsum is being used to manufacturing this type of product. These products are high strength, no doubt, but it's not an environment thing. Then going to the next part, PPC is a Potinora based cement, is a fly ash based cement. This is a very good cement for sulfur attack, or when you do a coastal area, both available here, PPC and PSC, and we can see the durability is much better. And there you can see that the carbon emission is around 582. When you go to the piece, it is a totally a slag based cement. This one. It is a slag based cement. What happened here is where the clinker factor reduces like anything. Because slag, the granulated slag which is being generated from the steel plant is having the properties of cement when the glassy content is more than 85%. So what happens with that slag when you grind fine along mixed with gypsum and clinker with very less quantity of the clinker. Suppose here it is 99%, here it is 60%, here this 30% clinker is doing 30-35%. So one is key with 1 ton of clinker, you can make 3 ton of cement. 1 ton of clinker, 1 ton of cement, roughly what ton cement, and here 1.4 tons cement. So that means if I make slag cement, then I am helping the nation. Here you can see that roughly 370 to 380 kilocalorie kg of CO2 is generated for 1 ton of slag cement. Now another cemented top, which is the strength is between these two. Some products which I can say that the strength requirement is in between these two, and then you that type of product that is composite cement. And this is new edition, means new edition is not very new, around 8 years back, 7-8 years back, this was added.
So this cement is again a mix of slag and fly gas. Suppose in a steel plant where you have slag and fly gas, so we can use as a grinding station there and produce this type of cement. That known as the composite cement. That also is an environment friendly cement. So, as of now in India, there is no green leveling of the cement. As of now, it is not started. We are discussing with the BIS for green leveling of iron and steel, everything. But as of now, it has not started. This all three comply to green cement based on the ITAR standards. So, which I discussed the same thing. This is the ordinary porcelain cement with 95% of clinker and 5% of gypsum. That was the Portland polymer cement, 60% of clinker, 35% of the fly ash. These are the BIS guidelines, and 5% of gypsum. And the Portland slag cement, where you can go up to 25% also. Normally, we would do it 30% to balance that. And 65% of the slag can be used there with 5% of the gypsum. Similarly, the composite cement you can mix with slag, fly ash, and clinker and produce the cement.
So, if I ask that, how do you classify the CO2 emissions? So, there are three scopes: scope 1, scope 2, scope 3. Scope 1 is which is within my boundary. Whatever the activities in the plant I am doing it, that is the scope 1, where I have the control and where I have a system and processes to measure, and I have the control of one end to another end to ensure that the right process is being followed. So that is the scope 1. And it is more on like the key, how do you improve that? It is improving the efficiencies of the plant, both in terms of thermal efficiency, in terms of electrical efficiency, in terms of operativity of the plant, in terms of the reliability of the plant. All this plays a very vital role on reducing the scope 1 emissions. Then comes the scope 2. This is the indirect emission generated from the purchased electricity. Whatever the electricity I am using in the plant through grid system, that is known as a scope 2 emissions. You can say that, do I have a control on this? Yes, I have. Because if I reduce my energy consumption by improving the efficiency in the system, both in terms of high efficiency motors, high efficiency system, improving the productivity of the equipment and improving the reliability of the equipment with digitalization, yes, definitely I can reduce it, and I can reduce the scope 2 also. And scope 3, it is both inbound and outbound logistics. So earlier the focus was more on scope 1, now the focus is on all 3. Why all 3? Because ultimately the end-to-end, if I see from the mining to the end customer who is using any product, that means it covers all the scopes. And because of that, you need to also see that what additional things you can do to reduce this. Suppose in a cement plant, you can say that suppose scope 1 is say 600, scope 2 is around roughly 25, 20, 30, or scope 2 is 70, 75, and scope 3 is 24, 25. So if you see that way, then everywhere we need to do. Of course, the first thing was to focus more which are in-house, and second, and last, the scope 3, now a lot of digital intervention has been taken place on logistics, both inbound and outbound, including EV. So that has helped us to reduce this part also. Though the contribution of this is less, but the reduction is possible here because of the intervention of logistic initiatives with RFID technology, with GPS technology, with geotagging, and many other initiatives have been taken by all the logistic initiatives, by all the logistic platforms. That is helping us to reduce this loss both in direct dispatch, multi-handling capabilities, all these things.
And just to add to just like scope 3, this is for civil industry. But fuel, like oil and gas industry, scope 3 is
Very,
they have
very true. Because that is only the logistic part in the way.
Because all the petroleum products is there.
Yes. So there are two things. One are the short-term measures, and one are the little bit mid-term and long-term measures, you can say. So what are the short-term measures to see that you can say the primary measures? One is alternative raw material. What are the alternative raw material I can use? Instead of say iron, limestone or bauxite, can I use some alternative raw materials which can replace some part of this material? Maybe the byproduct of some plant can be used. Like I can say that the aluminium byproduct of red mud, that can be used, it's a waste for aluminum production. That can be used as raw material for cement manufacturing. Similarly, the phosphogypsum, which is for a fertilizer industry, it is a waste which can be used as a gypsum for cement manufacturing. Similarly, if you see, there are some products which are lime content can be used in our system so that I can replace and reduce the CO2 charge, which is possible to do, and we are doing it also in many industries. Then energy efficiency, which I discussed at length, existing plant with efficiency technology, because if you see cement industry is evolving like anything, and if I see 30 years back, even it's steel also or aluminum also, the power consumption or the thermal consumption used to be 1400 kilocalorie per kg of clinker, which has been reduced to now 650 kg. So a lot of evolution are taking place with technological advantages, with improving the productivity, with reliability. That has helped us to optimize our energy consumptions. Then comes to alternative fuel, which I discussed about the alternative fuel. There are many alternative fuels which are available, which can really help us to reduce the use of the fossil fuel, especially the municipal waste, the RDFs. There are many hazardous waste which are having calorific value, can be used in the system to replace the fuel. And why I have written the collaboration and knowledge sharing, because this is also very important topic. You can see I have many collaborations we are getting to understand. Even you can see that there are NCBM and there are many industries or industrial houses or the houses which are helping to collaborate each other and do the benchmarking to understand the best practices of each can be copied by the other plants or other industries. Then if you see here, what is the sources of energy? Nowadays, if you see here, the WHRS, what is that? Waste heat recovery system. Whatever the heat which is getting generated during the process of manufacturing of cement, especially the clinker and the steel also, the waste heat, the waste gases which are having heat value. Suppose in a preheater, the temperature is around say 280 to 290 degree gases are there. In the cooler, the temperature is around 430 to 450 temperature there. How can I use that for generation of electricity? So that is also started, and people are now utilizing more, investing more to ensure that all the waste heats which are available in the system, how to maximum I use it so that I can generate at free of cost the gases, only the operating cost, running of the things. Then comes to renewable energy. Renewable energy again is a challenging subject, because if I use only solar, either in-house or beyond the meter, that is offshore, then again because of the sun intensity, it changes. So how do you use it? So a lot of technology has come. Now either wind or solar was done separately. Now there are hybrid things are there, solar and wind, so that we can use the hybrid technology so that the consistency of power improves and I can utilize more percentage of the renewable energy. So I can say that the way all industry has started for using of the renewable power, renewable energy, people have gone up to the 50% level. That means age of today, the manufacturers, they are working on WHRS, solar, wind and hybrid, and able to achieve around say 50% of their energy consumption through renewable. And that they are helping to the CO2 reduction. Going forward, the plan is that to reach to the level of 70 to 75%. And 2-3 more developments are coming here. One is the battery backup, which all know. Second one is the pumping. Once you pump it, and again in the right you can run the top back. So this I have seen plants in Europe also, they have done that. So in the morning hours, when the power is cheap or where they get generation of the power from the sun, they pump the water to a higher level, then in the night they run the turbine.
Pumps too.
Pump storage, exactly. Then process or logistic optimization, yes, this also helps a very important digital tool optimization which are helping us to improve the productivity. Then automation, real-time monitoring of every system to see that how can I improve my efficiency of the system, whatever the plant. It's not that applicable to only the plants which are talking on the cement or iron. Any plants, if I do a digital, then definitely we'll see there is improvement in the productivity. Then circular economy, that means whatever the Indian waste I'm generating. Recently, if you see, of course, this is the little bit new in India, like whatever the construction wastes are there, that is being used to make aggregates, and that is mixed with some percentage which is allowed by the BIS also to use in the concrete, so that the construction and demolition wastages can be used in the system. So more policies need to come to ensure that the way we see in any of the street, in the both the side, they put the garbages like construction waste, and that will be really useful in a due course of time. And what are the long-term measures? It's not exactly long-term, it's a mid-term measures. Hill electrifications. Because now, as of now, this is just a development stage. Whatever the clinkering process, we are doing it, both in the steel also, steel there is arc furnace, they have already furnace they have developed. So, how do I run the kiln without fuel? Only electricity where I can manufacture clinker. For a small scale, large scale strikes already started. But how do I see that is commercially viable and giving the right quality of the clinker so that I can use that to reduce the CO2 emissions? Then, storage, battery and pump hydro system, as you rightly said, these are the areas where you can do a lot. Then, hydrogen fuel. I think yesterday only, yesterday, the railways declared that the first engine they will run by 31st of March, the hydrogen engine. So I think first trial was, yeah. So similar way also, the team is also working, the research teams are working with collaboration with European countries to see that how can we generate the green hydrogen. You can see that there are 7-8 varieties of hydrogens, but the most important is the green hydrogens. How can I generate the green hydrogen and use its necessary?
Hydrolysis.
Yes. Then comes the electric mobility. Because nowadays, earlier the thought was only to start the electric mobility of the cars. Gradually move to a slightly bigger vehicles, where we have two destinations which are known to each other, like one distance from one end to another, where the continuously flowing of the vehicles are there for transporting of any mineral or anything, that is also done. But now, in the mining sector, I can say a lot of EV things are coming up. And China, they have done excellently well on EV. In fact, many companies in the mining sector, they have started using even 70 ton, 100 tons, even we started using 70 tons capacity equipments running with EV. So that means electric vehicles of 70 to 80 tons, which we were never thought of it, now it is there in the market and we are using it. That is reducing the cost like anything. And the charging, earlier the thought was that if I charge it hardly 2 hours, this will discharge or I need to charge again. But now the battery life and other things are such high, that means around 500 megawatt batteries. So that is helping us to run it for 6 to 8 hours even. So a lot of mobility has been started on EV. And petroleum products also, how can I reduce it so that will help us to reduce. Then this one is the thing which after doing everything, if we are unable to, what are the residual which is available from the system, where the manufacturing system or wherever, then this technology will come, carbon capture and reflection. I will discuss on this in the next slides, but this is also a very important, because ultimately our objective is to reach to the net zero, and to reach net zero, this is also equally important. But as of now in India, none of the manufacturers or none of the trials have shown that there is a real with low cost solution on the system. Yes, people are working on it, They are having a joint venture in many companies to work on this area. But even I have a discussion with the Hyderabad company who develop the small scale the prototype to see like how it works and what are the cost benefit and other things. But as of now, this is just a new beginning, and we need to do this. Plus, as of now, it is not making sense because carbon tax is happening. So once the carbon tax is there, then automatically it makes sense. So here is just I'll show you that just a snapshot that where we are today and by 2070 how we want to do that. Suppose in cement, this is for example of cement I have shown to you. 2024 to 2030, what are the activities I will do? All up in India, we done. Yes, technology for energy efficiency that we discussed. Blended cement, because I need to increase the share of the blended cement. In India, the OPC orality, if I can see, it's roughly around 27 to 28%, or 30% you can say. Whether I can reduce it to bare minimum 5 to 7%. Then, alternative fuels, people have started using it. Some plants have reached to the level of 20%, 25% also. So how people can copy in all the cement industry, all the iron industries, steel industries, they can use that and really save the fossil fuel. And pilot also CCU projects, because this is the thing which is going on. Renewable source of electricity demand, because people are now working on the renewable energy. Everyone is working on the hybrid mode or the solar and wind energy. How do they escalate on this journey? Even if you do this by 2030, it can reduce to this. Then from 2030 to 2050, if I scale up everything with improving the TSR, thermal substitution ratio, adoption of different varieties of pozzolana cement or calcined clay or limestone cement, all these things, CCU project, electricity from non-fossil sources 80 to 90%, which I discussed, even then I cannot reach to net zero. Then by 2070, if I do this, then also I will be there with 0.1 to 0.17. That I need to do the decarbonization, or some CCU methodology to reutilize that for the either CCS, sequestration, carbon sequestration, or carbon storage and utilization. So I will discuss the last part in the next subsequent slides. So what is CCU and CCUS? So carbon capture and utilization. This is the whatever the industrial processes are there. From the exhaust, how do I capture the atmosphere from the atmosphere? How do I capture the CO2 and utilize that CO2 for a real good form? What are the uses that also I have discussed, so that I can utilize those CO2 for a right form and continuously I am capturing and utilizing. So that technology is known as CCUs, but every time it is not possible to do that. So we need to have a mechanism to find out CCUS. That means I need to capture the carbon. Some part I need to utilize, some part I need to store it also. Because ultimately our objective is continuously operations are there. Some I can use it directly for CO2 requirements with different aspects. Then I need to store it for a future use. But storing, again, it's a costly thing.
Okay.
So these are the two things which are going in. But obviously, storing is also like that. If I pump it inside the sea with the underground, I drill the holes and pump the CO2 to the earth. So a lot of technologies are working to evaluate that which is the right process, which is the process which will help for a long run of the CCU and CCUH users. But as of now, this is the thought process which is going on, and this is the way the TV is working.
Yes, that reason.
If you see, there are three solutions if you see here. One is the primary, whether I can directly use with the fossil carbon-free fuel, then there is no requirement of CCU. Then during the manufacturing process, can I do it? Then process output. What are the once you complete the process output, how do I capture that? so that I can, during all these stages, I can do it and I can capture the carbon emission. Here it is the CO2 which is captured, and sequestration means what are the captured carbon is are there that I am storing it the underground. That is sequestration. And if I am using it directly in the CCU with the conversion of carbon neutral fuels, ethanol, then chemical synthesis, there are different synthesis we are using for CO2 reduction requirement. Carbon mineralization is also used for the construction purpose. Then algae cultivation, which is also a requirement where people have started in the plants, although in the plant they have put a duct there and they did their algae cultivation also.
Oh, Lord.
Then non-conventional ways enhance oil recovery. You may say that what is enhanced oil recovery? If I inject the high pressure CO2 in the oil wells or the area where the oil is extracted, then what happens? The pores which are developed or pores which are there because of that carbon dioxide injection in the mother earth, then what happens? This pressurize the oil and the output of the oil also increases. So this is also a theory and a thought process which is going on, where the recovery of the oil will also increase and the storage of those voids can be created with the use of CO2 when we store in that voids. So now it comes that the
Sir, normally air is used for extracting the oil. But it started CO2 injection and
no. This is just a thought process which is going on. This discussion is going on. I have not seen. Sir can guide you more, but it is just a discussion and the process part. It is the discussion because CCUS. It is
$1 million guys who can develop the economically viable CCUS.
exactly. So that is the thing. This is the theory part I am talking about because the practical aspect people are working on it because this is a very costly method. Only one plant they have done. I think Heidelberg at Europe. They have started just a prototype plant only. In fact, Holcim also, when I was in the SEC part of Holcim, there also we started to work in one plant in Europe. But it is very costly.
Very costly.
Very costly. So, it's a digital transformation.
Chevron CCU part of the S part.
S part.
Yes, process.
S part.
But a lot of biogas companies are doing in Canada.
Yeah.
Shell is doing, Petroleum is doing, they are trying to capture.
Yeah.
But because I 100 carbon abatement sector, they can't abate carbon, right? So they are doing.
So, US is very good because if suppose I take that key per day I am producing 10,000 clinker. So that means you can say 5,000 tons of or 10,000 clinker is equivalent to around 9,000 tons of carbon. So what to do?
What to do? That's,
I think that's the way the quantum is very high. So here if you see, so I was talking about the digital transformation. Why it is important? Because this is the technology has evolved like anything. The digital AI IoT, which is really helping us to reduce our consumptions both or improve the efficiencies, I can say, in terms of fuel efficiency, in terms of power efficiency, electrical or thermal, I can say. Third one is reliability. Fourth one is reducing everything, wastages. Because ultimately, if I reduce my wastages in whatever times, that means I am saving CO2. I am reducing the emission of CO2. So this is really a game changer, at least for the primary measures. I know that we cannot reach to the level of that level, but at least 5 to 10% I can do with improving the performance.
Okay.
So what are the advantages of this digital transformation? So what we have given the name is plants of tomorrow. How do I see the plants should run tomorrow? And today I need to work on that area. Then only I can see that I can visualize that tomorrow my plant should run like this. And when I plan like this, then what are the benefits I am thinking? Obviously, operational efficiency and cost is again a matter of because ultimately in a business we need to also see if the cost is less, then my profitability and my spread to the market also improves. Reduce energy consumption, which I discussed, improve productivity, product quality also, because there is a consistency that helps us to improve the product quality, which we discussed that if the quality of the clinker is good, then definitely if there is a start stuff any equipment, you are not going to get a good product. Any industry. So that will also help you to improve the productivity of the system and the productivity of the quality of the system or quality of the products. And obviously, when you have all these things, whether reduced breakdown or zero breakdown, then obviously that will improve the safety, improving the following the SOP and SMPs.
Nice.
Then better customer experience and advanced supply chain capabilities also. Because you plan it properly, advanced planning can be done with all this running of the equipment of the plant. So that overallity point of no waiting time will be there, no wastages will be there, no double ending will be there, no triple ending will be there. So if I see from one end to another end, it will total efficiency improvement when I have a total digital solutions on this. And how do
Can you go back to that slide?
Yes.
Which are the sensors you are measuring here?
which are
Which are these initiatives you are measuring here?
yeah, you can see that if I reduce the energy consumption, I reduce
Traffic consumption. Where is measuring here?
no. What happens is when we calculate the CO2,
How do you calculate?
just I'll tell you. See, CO2.
Software you are using or any sensors you are using?
No. It's a totally based on the total electrical consumption, electricity consumed, total fuel consumed, total petroleum goods consumed. There is a formula, and how much you
Produce
produce.
your software, you are not using any software for calculation. Suppose the motor is running. Say for example, if you calculate how much CO2 you are emitting, that also related.
No, that yeah, we do that, but not exactly the for motor wise. But the only thing is I can know that how much power is consumed per motor
On average.
on average.
On
So
average.
you are not going to the unit basis.
On average.
No. It is possible to do if I know that suppose there is an energy management system is established in every plant. Then I know that this motor consumes high energy. Then I need to replace this motor. Or this section is consuming high energy. I can replace this. So you are right that per unit, if I know that it's a 0.9, then automatically it can be multiplied and
It's more on the generic side.
yeah.
It's not going by units. Okay.
Yeah. That nice.
So, how do you see that the leadership drive? Because I know any transformation project you take, obviously you need a leadership drive to change that, and obviously these are nothing new, so that I can discuss with you. But these are the leadership you need to drive where the leader is really ready for with a vision and with the talent people and with the change management process with proper resources at the plant. I'm sure that there will be a good implementation, faster implementation of digital transformation in any company.
Which next?
So this is like if I just give a snapshot of how it helps to optimize. Like if you see the role of AI, optimize production process, because we have used many optimizers, and these optimizers help to run auto mode with AI ML mode, and that is really helping us to reduce the carbon footprint by improving the efficiency of the mills. Just I will give an example. When you deploy the high level controls and with the automated learning model, then that automatically improves because there is a PID loops are created inside the small from PID loops are created, which is really helping to automatically instead of operator who is operating the plant, instead of that the system operates itself, and based on the data which are being generated and the learning models with every second, which is helping is to run the model to run the plant efficiently.
Hi, pieces.
Take care. And similarly, the real-time monitoring equipment energy use, which we discussed, sir. These are the monitoring the real-time equipment with the energy management system to identify where we can improve, and that is really helping when you have a proper dashboard system and understand that these are the energy sources. If I monitor it properly, then really it is giving a good benefit when I implement this IoT steps. So this is a smart factories which I discussed in the plants of tomorrow. These are smart factories like when I have a data integration with the SCADA and DCS, where we have all the plants now which operate under DCS and SCADA. Then AI model development. This also we can use the generative AI models, so that also helps, which are high level controls which I discussed this part. This is really helping AI ML models. And people are now deploying in many plants to optimize their performance, optimize their quality. Even I can predict and the quality of the products also with this technology which I have deployed. Then comes with all algorithms, the multiple configuration process, all these things we can do it with available, because now there are a lot of startups, including the big houses also, they are offering very good solutions for the manufacturing processes also. And you can say that the raw material optimization. There also you can see that a lot of optimization softwares have been come with mining, the data mine, the survey, many activities has come which is helping us to conserve the natural resources and also ensuring that the right quality of the raw material is starting from the mining to the end product with the stage by stage with the robotic application has established. So this area, I think smart factories, I can say that once it is being deployed on some plants, it is already deployed. You can say that to the robotic lab, we have already deployed. So that is also helping us to see that without manual intervention, how do I collect the samples, how do I test it, how do I again finally whatever the test results are there, that goes the command to the DCS to correct the baseline. So it's a complete loop PDCA, or you can say that whatever the quality, whatever the stage wise changes are there, that is automated from the robotic lab. This is like soft sensors. Like if I put a soft sensors where it is with the AI model, if I do it in the mills where it is giving 1 to 3% reduction in specific power, fuel consumption 2 to 5%. These are the live examples where it has been done in industries with the use of this digital technology with AI and soft sensors and mill optimizers. These are
Are you utilizing now? Are you practically utilizing?
Yes. And even the mill optimizer, the plane residue maintenance, plane prediction, everything I can do. Only thing is first I need to run the software for at least 2 months. So that when it is ready, that we automatically captures the data with different patterns, different types materials. Then automatically we get that once you run the model after having the data, then we get the right things both in terms of blade prediction. So sometimes you can say that without CCR operator also I can run it. Once I have a proper license. And this IoT and AI-based predictive maintenance. This is the subject which is going on now to improve the predictive maintenance part. And like if you in a plant, if you see that 20,000 equipments which are operating, rotating, and we are producing any of the products, then these IoT sensor of the critical equipments will help to help. These are like sensors of wireless sensors, and these can be. There are many suppliers who give it with a proper mechanism to collect the details through a dashboard system to understand that how my equipment is running, what is the bearing condition, what is the temperature. These IoT sensors are helping us to predict the condition of the equipment, and once I know the condition of the equipment, then I can take the right solutions to take the preventive maintenance or stoppages before it fails. And that really helps us to understand that what we need to do. If I have a standby arrangement, I can run the standby and see that whatever it is that I can really work on those areas, and that will help to improve my uptime of the equipment and reduce the failure that I can say. Already this has been deployed in many companies, and this is giving a good result.
If you integrate with the entire marketing and demand system, the whole thing can get automated and it will be a closed circuit.
Agreed, sir.
You agree with it?
Yes, sir. That is also there. I will come to that. Yeah. So, what are the this you were talking about the logistic solutions? That is integrated logistic management system. So here also, because we were talking about the logistic management system, that the scope 3, where these are the challenges And all logistic people who know, who work that they know what are the challenges in the logistic. I don't need to explain each and everything, because nowadays, because of the good logistic platforms have been created, many good platforms, including TCS, I can say, they're also with a very good platform. So that is helping us to reduce the number of clicks, because we know that we turnaround time, how can I reduce my turnaround time both inside and outside the plant complexes, and can track it, can monitor it, and ensure that which are the segments I can need more focus to reduce the losses. Plus, this also helps us a better utilization of the fleets, Earlier, whatever the fleets were used for 100 fleets for suppose I am producing such X quantity, with same 100 fleets I can produce X plus Y quantity. So that is the advantage we got, and apart from that, the lead distance also reduced. Plus, the proper tagging has helped us to find out the right route. Many times it may happen that with the logistic, the driver follows the one route only. But when you have a proper system with a proper understanding that you can know that this is the new route I started, we can do that. And sometimes you get an alarm that this route is like in the Google also, when you go to one distance and other distance, there you found that you can follow this alternate route. So all these things are helping a lot to faster delivery. And if a faster delivery time is executed, then no need for the warehouse also. I can reduce, not that it's zero. I can reduce the warehouses, or I can say that I can improve my direct dispatches from plant to the customer. That means double handling, triple handling, secondary freight, everything can reduce, and I can save a lot, both in terms of for the profitability of the company, logistic cost, and third is the reducing the CO2.
Starting from the demand analysis, across marketing, across the entire production cycle, back to services and the closed loop system.
Agreed, sir. That is
you can do
S&OP, sales and operating plan.
Absolutely.
Yeah. So this is reduced turnaround time, reduced scope 3 CO2 emissions. These are the advantages you will get for the system. Reduce uses unsafe acts also, because when you work in the plant, if they want to reduce the drivers and other things inside the plant, they need to reduce because they are not conversant with the system and processes. So how do I reduce their involvement only to the limited time, the limited area only? They should not go to here and there, so that the safety incidents will create a problem. 100% visibility of the orders, because that is also equally important. Then only you can reduce the warehousing. Then real-time update of the data and everything. So one part is obviously the business advantage. Second, more important is that helps us a lot to reduce the scope 3 emission also. And this is a snapshot which rightly said, sir. These are the snapshot we can say that how the GPS is being tracked, how the road map is tracked, where the truck is there, where the zone wise is there. So we can create number of dashboards, whatever as per your requirement, to understand the business dynamics. And obviously, rightly said, sir, whether I can convert into everything to a CO2, how much I have reduced CO2. I think that's a very good suggestion that can be also incorporated.
And once the drone technology comes, the whole thing will go under metamorphosis.
No, even sir, I can say that I have started using drone technology in other plants. So we are doing the surveillance with the drone technology, and drone technology not only for the surveillance of the plant, but with AI-enabled drones, which are helping us to give indication, to give alarm if anybody is doing unsafe thing, if anything is going wrong, including the fire and other thing, automatic alarm comes. Then our rescue rapid action team is there. They are really going to the site and taking action. That has reduced or improving the overall security and safety of the total system. Apart from that, there are drones which are now being used in the maintenance practices also. Earlier, if you see that for a chimney of say 100 meters, it was very difficult to inspect the chimneys, both in terms of the safety or the structural stability,
Condition monitoring,
structural stability, and even putting the scaffolding to go there and inspect. But now the time has come that we are using drone and see the very good clear images of that. Similarly, in the confined space, where in the silos, there are big silos or 1 lakh ton silo, there are cement silos of 10,000, 20,000 tons, there are silos of fine powders are there. When it is required to go inside, it is a very danger. So first we send the drone and see that everything is safe, then it will enter. There are cyclones where it can be used. So my point is say that the technology is helping us a lot to reduce the downtime, to improve the efficiency, to improve the safety also. So what are the road ahead? I think this is, I can say that we need to see that what as an individual we can do.
Yeah.
So I'll talk about the people, how we can contribute. We need to improve our knowledge. So capacity building and support for policy change. Sustainable lifestyle we need to do. And obviously EV or hybrid vehicle, if I buy a new, I should see that whether I can go for EV and hybrid. Reduce, these are the 3 R's which you know. Sustainable food system excellence. This is very important. The foods which are generated near us, I should use more. so that I can reduce the logistic cost or logistic footprints. Then forest and land restoration, this is very, very important. Because we need to support for the afforestation and reduce that. E-wastage and preferred in the cloud instead of the drives and other things so that I can reduce my e-wastage. So these are the individual we can contribute for the CO2 reductions. And here I have just mentioned one thing. You just see here. Suppose I use public transport as a carpool when I go to office, where I go to for a year I can save 780 kg. If I reduce 10 km per day, if I use 10 km per day for going to office. Energy efficient, like now you can see that 4-star rating, 5-star ratings are there. Then I can save 300 kg. Recycling aluminum, whatever the cans we are using, whether I can properly dispose it so that recycle can be done, then I can use 108 kg. Then, if I reduce the meals, of course I should not say this, but this not meals, meat meals.
Turn vegan.
Yeah, you're right, ma'am. So then I can save 936. I just want to tell that I attended was conference. There was a lot of discussion done, and nowadays people have started converting the conferences from non-veg lunch or dinner to veg. Why? They are reducing 40% coming. So this is one such thing which can help us to reduce switching renewable energy. Very good roofs, solar roof, or solar wind. There are many things are coming of.
Not only that, we go natural. Uncooked food, that also reduces.
Yes, sir. Then, if I limit my travel, if I long haul travel, if I reduce one, then I am contributing 1600 kg. Then, water, energy, if I properly use a tap and properly tap also, if I use it properly, sprinkling tap instead of putting directly the water, there also I say. Then, eating local and seasonal foods, because this helps a lot instead of transportation and logistic. Then supporting sustainable brands, the brands which are doing sustainable business. If I promote that, then definitely they will. I am indirectly contributing that. And obviously, planting trees. If I plant 10 trees, each tree gives me 22 kg.
CCUS, natural.
Yes,
on point number one,
22 kg.
on point number one,
Sir.
one drone technology takes off further. Today you are using it only for cargo from Gurgaon to Delhi. Tomorrow you will be sending by transport. You will have a drone at the top of your building.
Yes, sir.
And travel as the crow flies. And you won't need a car and the roads and blah blah blah.
Yeah, you're right, sir. You're right. The technologies are there, and how effectively you can use it with the least cost. So this is what we can do as an individual. I thought that that will help us to know, and we can at least do some one or two things also. Then we can contribute for the nation or for the world. Right. And what are the advanced technology which will help us? Obviously, the green and alternative fuels. Hydrogen as a fuel, renewable electricity uses, we need to promote that. Digital interventions where I can improve my efficiency, amount will be less, the percentage will be less, but yes, I can contribute. E-vehicle uses, supply chain and mobility, people have started it and that is helping also. R&D investments, continuously everyone has to do the R&D investment for the low carbon products. Then, obviously, CCU, because this is I kept it last, because this is the last measure we should do. Other than this, we should complete all this. Then comes the key, as a policy point of view, because we are from industries, we are from experience, more than I think 1,000 year experience here. So we can, as a policy, help green product certifications. Then promoting low carbon products. ARMs, alternative raw material uses, how to make a policy to use minimum such percentage of ARMs on such percentage of AFR, carbon pricing and carbon credit and pricing mechanism, discussing with Kandan on this, and carbon exchange mechanisms. We need to, though it is started and the platform is started, but not to the level which it is to be done with a proper policy and other thing. Then incentivize low carbon product uses. Suppose now I think there was a discussion with DIPP also, some activities going on, like if there are any mines, they'll be using EV vehicles and they will give some benefit for that. It is just an initial stage of discussion. So lot of things need to be done on the policy point of view, including the BIS, including the DIPP. Everyone has to help, including the policy makers, so that we can really ensure that we are producing the green products. So that's all from my side. I thought that I'll have a detailed discussion on this. And we can place for the net zero, be the planet's turning point.
Have a share. Sir, as I know, cement industry they consume very huge quantity of coal per day. Correct? And now this coal means is in red. Cement comes. Now you are changing this coal from normal coal to fresh coal and some other coal. Now, normal coal has a disadvantage of high ash content, but low sulfur. Petcoke is having very high sulfur, but ash content is almost zero.
Yeah.
At the same time, petcoke is having double the kilocalorie, emissions.
Yeah.
So now that what are carbon content?
Yeah.
How much you are replacing this coal or petcoke by alternate fuel or other emissions?
See, so as of now, the technology which are developed without having chlorine bypass. Without having chlorine bypass, we can go up to 20 to 22% or 25% maximum on the alternative fuels for replacing either petcoke or the normal coal. Then, if I have a chlorine bypass system, because the municipal waste that is having a chlorine, which I need to reduce the chlorine in the system, in the clinker, as per the cement norms. So I need to have a chlorine bypass, which I can use the chlorine separately in some other mechanism. Then I can go up to around say 35 to 40% also. But it is just one or two plants they have started it, not all the plants. But I can say that only if I say that this I use RDF, hazardous waste or biomass, then I can go up to 25-30%. But beyond that, I need some modification in the processes, system, and now people are like some countries like KSD, they have developed like pyro rotors. So there, where we can directly I can use instead of shredding the municipal waste, I can use the raw in the wastage up to 1 meter, 2 meter size also. I can produce the gas, and that gas can be used in the system. So it is like secondary burner which I can burn it and I can use in the system. So a lot of technological interventions are taking place, but I can say that yes, in long run it is possible to do. Yes, it is possible to do go beyond 40% also.
I have just one question. Initially, you said that to achieve net zero level, you will have 1.5% reduction in the carbon. So, why 1.5%?
No, not reduction in the carbon. This is the temperature already raised in the temperature.
So, temperature 1.5%. Why 1.5? Why not 2 or 2.5? What is the basis on which you consider this, that temperature level? One. Second is the global achievement time is kept 2050, India kept 2070. Now Donald Trump has come, he has pulled out of Paris Agreement, right?
Yeah.
So what happens under these circumstances? This, the achievement level will go beyond 2050 or even, the 2070. So
it's very difficult to answer the second one. The first one, I first answer the first. See, 1.5, there was a debate on the 1.5 and you rightly said. But your FCC have declared that you will have 1.5 with 2020 is the maximum.
on what basis they have this?
They have calculated that the temperature of the earth has increased and the temperature of earth has increased to a level of 1.5. You have to maintain that 1.5 degrees.
From what time to this
Pre-industrial to now.
pre-industrial?
Yes.
That means is it
1904
industrial revolution?
1920s, 30s, yeah.
Sir, whatever fuel started,
Yes.
that is being developed, and 1.5 is the calculated.
Then they wanted
1.5 degree will be huge climate change.
Yes.
Beyond memory.
So what about the food vendors? What awareness are they? Corporate is doing a lot of job.
This is the food vendors also. There are some policy guidelines. I'm not sure that exactly, but if you go to the website, there are some guidelines that given, like environment friendly of 1 billion, which you are discussing. That also includes the food also. Because what type of food we should take, what are the type of, like I told you, if I use the country made or the local foods, then I can reduce. So all those things are the pro style that will help to reduce that.